They are legal in New Hampshire, but they are disapproved of by the Fire Chiefs Association.
They are L-E-G-A-L, legal as opposed to illegal.
They are legal in New Hampshire.
The other rule of thumb with them is for every pound of fuel you burn in that thing, you get 2 pounds of water out. So you can wet a house real easy with it. I don't know what she's going to do. I talked to a woman last week, and she claimed her siding was rotting off because she put spray foam in her old house. And after an hour on the phone, she finally said, and yeah, I had an unvented propane-fired heater in the basement I took out of my old home and ran in the house after we foamed it. And there was water dripping all over everything inside the house. So, okay, let's get something straight. Your clapboards didn't rot because of moisture from your house, because the foam keeps the moisture from getting to the clapboards. They rotted because you put them directly over Tyvek, and they can't breathe, and the Tyvek lets water get in there and stay on the sheathing, and then everything rots. And we know today not to do that. We sell home slicker to put under clapboards, so there's a drainage space to let the water leave when you're going to build a house today. But so you can add fan-powered makeup air. That's what that unit is. It sucks room air and outside air and blows it into the furnace room. Big issue I already mentioned with you folks is generators. That's actually hooked up to work as long as this pipe stays sealed in that window and there was wire holding it there. So, you know, how permanent is the installation? How well is it installed? Do you want to risk hurting someone or not? So the suggestion from Terry and I was, if you're weatherizing a home, don't leave unvented combustion appliances in it. If you got a gas stove, you really ought to install a range hood over it, because a gas stove is an unvented combustion appliance, and if you use it a lot, the minute gas stoves with that nice blue flame don't produce carbon monoxide. The minute I put a cold pot of water on it, it produces carbon monoxide because it quenches the flame. The reason car engines produce carbon monoxide is you can't run them too hot or you'd melt the pistons. So when the combustion happens, it hits the cold cylinder walls and you get incomplete combustion, which is why you get CO. If you made a ceramically lined piston and piston heads and valve chamber and ran the thing at 1800 degrees F and it was all glowing hot, you wouldn't get CO. But building an engine like that we call those oil burners, because that's the way an oil burner works. The hotter you burn an oil burner, the less CO you get out of it. The rest of the guidance is make sure you put a CO monitor in, make sure somebody's maintaining the combustion appliance. And it's probably a good idea to get rid of a vented device if it's old and performing poorly. And you got propane around. Steel combustion propane boiler or furnace is a pretty amazing device compared to old atmospherically vented stuff. We can't buy sealed combustion oil-fired stuff yet. The ultra-low sulfur fuel you're buying for diesels is not currently available for houses without paying the road tax. So without ultra-low sulfur, if you put it in a condensing oil burner, you get a sulfuric acid generator, and the manufacturers won't warranty them against high sulfur number 2. They took the sulfur out of diesel and put it where? Into the number 2, because it's burnable and it adds to the fuel value. But number 2 is like 6,000 parts per million S sulfur now. And ultra-low diesel is 15 parts per million or less. So there's no sulfur usually in propane or natural gas. The rest of the guidance is bathrooms shall have an exhaust fan, no more operable window. It shall have an exhaust fan that's quiet, that's then BPI tells you how to check it out and how you can do it, and tells people how to test it with a squirt chemical smoke or with a pan type tester. Anyone ever had, did you guys have a pan tester here? I noticed you got a Retrotech hood, blower door. Do
We
you
don't
have,
have actually, we may have a pan test right. If not, we're getting one, I think.
yeah. The way to measure low airflows on a residential basis is simply pressure drop across an orifice with a digital micromanometer. So that's a known orifice. This digital micromanometer measures the pressure drop between here and in there. From that, you can back calculate the airflow going up the exhaust fan. And usually weatherization crews make sure someone hasn't installed an exhaust fan in some crazy way. That's not the way to install an exhaust fan in the attic. Kitchens, we already mentioned, need to be exhausted. You need to exhaust gas flames in particular. The new guidance says, by the way, now that you've made this house real tight, it ought to have an exhaust fan that runs anytime people live there. And the current guidance, particularly if you've eliminated that atmospheric vent between the furnace or boiler and the chimney, so you no longer have a 50 CFM exhaust fan sucking air out of your basement all the time, the current guidance is stick in the equivalent of a quiet, low-speed 50 CFM fan somewhere that people can run to pull air through the house. And I don't care if you run just an exhaust fan. If you got sealed combustion, you're not going to hurt anybody with an exhaust fan. If you don't have sealed combustion, there's still a BPI test that says turn on all the exhaust fans in the house, fire up the combustion appliance, and make sure you don't downdraft the chimney from all the exhaust fans running. You've got 50 in the kitchen, 50 in the bathroom, 50 in another bathroom. That's 150 CFM exhaust. In an airtight house, you will pull that house negative. And with atmospheric combustion, you could actually pull it down the chimney. And that's just the formulas for figuring it out. That's the table. Basically says, I threw out 50 CFM. You got a 2-bedroom house that's less than 3,000 square feet. The real number is 60, but you know, 50 is close enough. Anything that's quiet that people could run. It could be a bathroom fan. They now make, Brown and everyone else makes quiet bathroom fans rated for continuous duty. Leave it on when anyone's there. Great way to get rid of odors, shower moisture, and pull air through the house. Because that's gone. You know, that's the swing damper in the basement that used to always let air go up the chimney. When they built the first all-electric homes, they had all kinds of moisture problems. And everyone said, oh, it's because it's too tight. And the issue is, all-electric home, that thing's gone. So the continuous 50 CFM exhaust you had in your basement for 20 years or in other homes is gone. So current guidance is make that box as tight as you can possibly make it so you don't waste energy and have the Europeans laughing at us, and put in the right amount of ventilation. That's what residential homes are going to. That's what commercial buildings are going to. The military is now pressure testing all facilities they bring online. There's a pressure tightness spec for the dorm, the airplane hangar, you name it, that you have to conform to get your building approved once you've built it for them. And there's frankly no reason not to do that as long as you put the right ventilation into it in a controlled manner. We also know that you need pressure balance distribution in a house. So if this is a top view of a duct system in a home, I need some way to let, if I don't have some way to let this air get to this corridor, then this is under positive pressure leaking out the window. This is under positive pressure leaking out the window. Somewhere I'm pulling all these other spaces negative. So the simple way to do pressure balanced air distribution in a house, so you don't end up sucking stuff from the garage. That's the garage door telling you, hey, all the crap in your garage is coming into your house. Is something like that between the hall and the corridor. And EFI, actually I brought catalogs for each of you. EFI has things like above door transfer grills, squirt foam, spray foam. EFI's been around for 30 years, and people actually want their products today, which they're real happy to be selling. And they sell all kinds of great things for people doing weatherization in homes or building new construction. So look at it at your leisure. This, I think actually, if you go to page 25, page 25, the green case there, that's the kits for single part squirt foam that you actually let the trigger off. Anyone ever use this stuff? Do they have any chance for ever doing hands-on foaming in anything you guys run for courses?
Not as yet. We're in the BPI program, we're going to be running an installer's class, I believe.
Cool, because that green kit with the needle down there that you can put on the end of the gun will seal down to a 1/16 of an inch wide hole, and you take the needle off, you can seal up a 3-inch hole with the same gun. If you're going to seal a 3-inch hole and mice would crawl through it, you need to put steel wool or copper wool or something in the hole first to just chew through the hole again. But pretty easy way to air seal with this hardware store stuff. Anyone ever use the hardware store cans? You let go of the trigger and you still get goop all over you, and this stuff works great. And then there's all kinds of other, if you turn to page 28, that's this spray kit foam where you can actually, you could flip over your hot tub and put an extra 2 inches of foam under it with one of these kits. Instead of heating the outdoors, you're actually heating the water. But that's, you need to make sure you aren't breathing those chemicals when you're working with it. All kinds of respiratory protection. So pretty amazing catalog with all kinds of interesting stuff in it. So physically that, you know, schematically might look something like this. So there's a return air in a hallway, and there's transfer grills above the doors. Those transfer grills actually go in, over, and then in again. So it reduces noise transmission between the room and the hallway. The rest of ASHRAE, ASHRAE standard, if they have any idea what ASHRAE standard 62 is from your course or anyone else?
Email saying that you can, it's free download now.
Yeah. Somebody just paid, whoever sponsored the development of it paid for free downloads for a year. So you can go to ASHRAE.org, American Society of Heating, Refrigeration, Air Conditioning Engineers, and download the standard for free, which usually costs you 40 bucks. There's another guide on there, Wes, that I think is the new indoor air quality guide. It's usually 190 bucks you can download for free. And it's like, you better have a good printer and you decide to print it.
Is that on the ASHRAE website?
Yeah. The rest of ASHRAE Standard 62.2 for homes says, by the way, in addition to exhausting bathrooms and kitchens, you shall vent the clothes dryer to the outside. You should make sure there's no backdrafting. You should isolate the garage. You should make sure some of the windows open. Any light fixtures to the attic have to be sealed fixtures. You can't put these cans in that let air go into the attic. You need to have a filter on any air supply. You need to have the air intakes for any air supply away from pollutants by a given distance. And you can use prescriptive duct sizing. You don't have to do duct calculations for a given size fan. And somebody has to tell the owner how to run all this stuff. Actually, you're supposed to provide some kind of guide to the owner. Your bathroom fan's supposed to be run wherever you're taking a shower. Of course, you can buy switches now in EFI that you can program. It goes in the standard switch hole, and it'll run for 20 minutes or 10 minutes or whatever you want to program it to after you've taken a shower. Of course, the switch is 30 bucks instead of 3 bucks, but Wes.
You mentioned the recessed lights. What's the appropriate way to deal with that when you have an old-fashioned one that, you know, is just open as a chimney into the attic?
The legal way?
Huh?
The legal way, L-E-G-A-L, the legal way. Replace it with a new fixture.
There's no way of air of sealing,
Because if you build a nice, what people have done historically is you take gypsum and build a box over it, you know, a foot away from it, and then bury it in insulation. The wiring in there isn't rated for high temperature. So now I built a closed box over a fixture with wire in it that's not rated for 170 degrees or whatever the number is. Now I risk a fire from melted wire because I insulated around the box. So my training is, and I haven't done any of that, is the only safe thing to do is pull the fixture out and put in the right fixture that's sealed with with a wire in it that won't melt if you put a bulb in it that's more than, even with the right fixture, there's still, don't put a, you know, more than 60-watt bulb in this thing because it's going to get hot unless you've gone to something that's better suited for. So most of you probably know that incandescent bulbs have been banned on a federal level and be phased out over the next 5 years. There's someone who's already found a way around that in California. What are they doing? They're selling light bulbs as heaters.
What?
Heaters.
Heaters.
Because incandescent light bulbs are great heaters. They're terrible at making light. So I don't know if someone's going to somehow plug the loophole or not, but yeah, they aren't light bulbs, they're heaters. So information to the occupants is, how do you run this house, you know? Trying to convince some occupants to follow directions certainly would be an interesting challenge. In many parts of the country, it's a language barrier. Trying to get them just to not do illegal things is an interesting challenge. So best practice by MIAQC would be, if you do a sealed combustion retrofit, don't do it if the basement's going to be left wet. Do you really want to take out that chimney? If I got a wet basement and I'm going to get rid of that thing that's been venting the basement for 20 to 50 years, and you're going to leave it wet, do you really want to do that? I don't know what the feds will say about this, but from a practical perspective, do you really want to have a wet basement and take out the chimney? You know, I walked into one in Portland, Maine 2 weeks ago. Little gooey down here, isn't it? Yeah, and you look over a brand new sealed combustion boiler hanging on the piece of plywood in front of the rubble foundation. Chimney's got a nice plug, you know, in it. So, interesting issue. Let's take a break. 10 minutes, what do you do? Figuring out how to grow stuff that you could get toxins from to kill people for the military. That was his research job. And he said he killed more lab rats with stuff he could grow from mold than any other material on the globe he could find. And it was easier to grow stuff from mold that produced toxins that were nasty from any other material that you could raise in a cage or find a frog or whatever. So mold in its worst form hurts people. For many people, I took it out. It's not in here. There was a slide in here that had a piece of cheese and beer on it. Oh, it is. Where is it? How many more?
Like 3 or 4 down.
More.
Ah, okay. So my brain's not working well. So buildings get wet from the site, from condensation, from flooding and leaks. The great news is there's meters for less than $100 which will accurately measure the moisture content of wood. They're called pin meters. Any wood that's above 20% RH moisture content is likely to rot and turn to goo. Wood that's below that is likely to never rot and turn to goo. What's interesting is that slide is in an attic, that's OSB, at the pitch of the attic. The south side roof is almost wet, or borderline. The north side is soaked. Where's the moisture coming from?
Inside of the house?
Air leaks from the house into the attic. The other place it could come from is nighttime black body radiation cooling. But for the most part, when something's this wet, it's moisture from the house. Nobody air sealed. You know, all the codes that tell you how to vent an attic assume no gross air leakage between the house and the attic. No cans, no holes around plumbing, gasketed doors on hatches, etc. They're aimed at water vapor, not at air leaks. They all assume the air leaks have been stopped. So the real issue with mold and moisture is, how do you not have stuff grow where you don't want it to? If you wanted an audit form for doing that, I brought in you the handout that Terry Brennan and I, did they have it yet? Not yet. The handout that Terry Brennan and I invented was partly taken from the Environmental Health Watch moisture audit. You could Google Environmental Health Watch moisture audit. It's a 16-page form that an auditor could fill out on a house. Okay? You fill out that form, it's not going to take you hours, but it would force you to think through, is this house going to have a moisture problem, or does it already have a recognized moisture problem when I do that? On this form, if you simply, so the pages I guess aren't numbered. There's the first page which deals with combustion. The bottom of the first page deals with bathroom exhaust fans and whole house fans. The bottom of the second page references that Environmental Health Watch moisture audit. And then it asks you to start looking on the right-hand side. Is there visible mold? Is the foundation wet or dry? Are there gutters? Turn to the next page. Is the ground interior covered? Is it not covered? What do the roof and attics look like? What do the exterior walls look like? What do the mechanical systems look like? On and on. If you actually, once you understand what to look for, this is a real comprehensive checklist of recognizing that there's a moisture problem in houses. Okay? If you got to go measure something, a moisture meter is something you might want. If you could leave it there, a relative humidity meter. This is the cheapest one I'm aware of. I bought 6 of these. I bought 6 of these last week and gave them out at workshops for $10 a piece. So there's no economic reason a weatherization crew couldn't leave one of these in a home, or any contractor that's doing renovation couldn't leave one of these in a home, in the basement or a kitchen or whatever, and say, hey, if this number goes up above 50%, call me, because that's too much moisture in your home. The issue is if you let the moisture in your home get much above 50, 60% in the wintertime, the windows are all sweating and you're wetting your attic. So the only other device I found that might work, and I don't have a bunch of these to give out, I found these things which are used in museums and cases. These are $1 a piece, and they're for checking humidity, again by color change. And a weatherization crew could read these, but you really got to be less colorblind than I am to figure out. You're supposed to read between blue and pink. So why don't I pass it down? If you had to read between blue and pink, say to yourself what the number would be, and then we'll see what the real instrument says it is. You can pass them down, and I'll ask you later what it says. Oh, there's the website for the Environmental Watch moisture audit form. It's from actually some guy in Ohio who did an incredible job of putting together this survey. Great form. Basically, what we suggested is you ought to walk through the house. If there's a moisture problem, fix it. If you can't fix whatever obvious moisture problems there are, you really ought to think about how tight are you going to make this house? And this case study at the end will give you a good clue as to you can cause some pretty severe problems depending on what. And weatherization crews usually wouldn't have money to fix site drainage issues. The biggest issue around rubble foundation is pretty simple. If this is where the rubble is, does the earth do this and fill the foundation with water every time it rains? Or is the earth around the house like this, and when it rains, water drains away from the house? This morning I was looking at a school in Milton, gorgeous 1890s brick building. Looks like the same architect that built the one at UNH that sits on top of the hill. One side of the building is like this. So guess what happens when it rains? The water flows in the granite rubble foundation and wets them. So pitch is real important around a building. The code says you shall drain the water away at a 5% grade around there. Any of you ever build a house? The real issue with backfilling around the house is no one vibratory tamps it down around the house, so it always sinks maybe a foot. You got a 7-foot backfill or 6-foot backfill, and you don't overfill it a foot and a half, it actually ends up sinking around the house 2 years later, and all the water is going in the foundation. You have to really overfill it, which is why some people won't landscape for a year after they build a new house. So wait till it all settles down. Anyone got a number? What do you think the thing reads? 30? Wes, did you look?
I thought between 30 and 40.
34.
Oh, good. And then, now, the good and bad news is this one says 31%. I don't know if any of you remember that from me holding it up. The last time I checked this $10 meter against a $60 meter, they were off by 10%. So I actually don't know which one is right. This one's been around 6 years. And it turns out it's real easy to measure temperature. It's much harder to accurately measure RH. I happen to own an $800 RH temperature meter for solving arguments. To use it, you have to decide you're going to calibrate it at 30%, 50%, or 90%, because it's only accurate around the range you've calibrated it at. Is that a sling? The other way you can measure humidity is with a wet bulb, dry bulb, and that doesn't have mercury in it, right?
Oh, it's still wet, okay. I don't know. Huh?
Maybe it does.
Are they mercury thermometers? No, red gauge oil. It's fine. Whoops, it's still wet is right. Anyway, so there's 3 ways we can see. We'll leave all 3 out. These actually agree at the moment. These are both saying 30%. No, 29. So. So looking at buildings is look at the drainage, the roofing, the attic, the basement, the crawl space, the windows, the walls, the HVAC units, sinks, toilets, look for drains, leaks, look for wet stuff, peeling paint, water stains, effervescence, condensation, mold, unvented bathrooms, dryers, fireplaces, ranges, humidifiers. Sometimes it's pretty obvious, you know. If you look at that in a basement, do you really want to weatherize that home? When I did the weatherization crew training, they said most of the crews would walk away from this because they don't have the money to fix it, and they know if they tighten that house up, every time the water comes pouring in there, it's only going to be more of a problem. So, interesting challenges. Sometimes problems aren't as obvious. That's effervescence from plaster in the ceiling. It turns out it's actually hard to get mold to grow on plaster. It's easy to get mold to grow on sheetrock because paper grows mold really easy. Plaster's the wrong pH. You got one, Wes?
1 second.
You need to figure out how to read it, right? Now, there's an interesting one. Brick, moisture from the earth is wicking up into the brick wall, and then the brick is actually spalling off, which is interesting. It's not freeze-thaw, it's so much moisture is coming into that brick that it's degrading and falling apart. Again, are you going to do something about that? Probably, in reality, weatherizing that home is a big risk. Probably weatherizing these is not, as long as the earth is covered with a visqueen or poly. Leaks under windows are a different issue. You know, weatherization crews usually don't have the money to go tear out under a window because the flashing was done wrong and it's getting so. If I insulate that wall, I'm only going to make it worse. Attics and roofs seal out the air that's coming from the home, plan for normal cold venting. If it's an atrium attic or someone's got a ton of ductwork in the attic, you might actually consider moving the insulation from the attic to the roof. Lots of people doing that these days. We already mentioned ice dams are caused by air leaks. Ice dam, you all understand what ice dams are. Water comes down, refreezes at the edge, then backs up into the house. That's the kind of leak a weatherization crew would go after. And you guys ever been in attics? I mean, frankly, once you're used to it, finding that stuff is pretty easy. And you know, a weatherization guy would get real excited over that because there's a huge hole. You know, that's probably 10% of the heat leakage out of the house, a hole that big. The only thing that would be worse is the 2-inch gap around the chimney someone left instead of filling it with sheet metal. That's probably 50% of the energy bill going up into the attic. There's your can lights, replace them. Put hatches on. There's all kinds of things now available to seal attic hatches. Possible retrofits are get some squirt foam over here above the top plate because there's no other way to insulate it, and then put your vent chute in and bury the rest of the attic in 3 feet of cellulose. My office had 4 feet of cellulose blown in and it settled to 3. So, you know, on paper it's ours 70 or 80. Why did I do so much in the attic? It's cheap. It's the easiest. Blown cellulose in the attic, as long as you built a gangplank to get somewhere, is the cheapest way to improve R value on a house. Wes?
How thick do you need cellulose blown in open like that for it to be an effective air barrier too?
The simple answer is it never will be. You should always rely on some other sealing mechanism to air seal an attic. If you've got a foot of fiberglass in there and you're going to blow in 2 feet of cellulose on top of it, send some brave person in there with appropriate respiratory protection and skin protection and a single gun and lift up all the damn bats and look for all the air leaks and seal them before you go blowing in. Seal all the wire penetrations, etc., before you go blowing in cellulose.
38% is what it said.
38. So that's 25, that's 30. So that would imply both of these reading low compared to, is that distilled water? It's supposed to be distilled water, so it could be affecting it, but
Really?
yeah, distilled deionized water is what you're supposed to use. Does it affect it or not? I don't know. I would expect any tap water in New England to have plenty of minerals in it. So, good question. So there's another retrofit. That's spray foam on a skylight. Skylights are brutal for trying to insulate. That's a different kind of retrofit. That's rigid foam up on the roof and netted cellulose under the roof. I did a variation of that on an atrium ceiling in a log cabin I own in Utah. My son and I screwed 4.5 inches of rigid foam on top of the existing roof, put down 2x4 sleepers on that with 8-inch screws into the original roof, then put down plywood and put a new roof over it. And that, we're presenting a paper at Efficiency Vermont in February. That's a 75% energy reduction by insulating the roof, the basement, and air sealing the logs. It's still a log cabin. It still has nothing but logs in the walls. But the proven energy bills after a year and a half right now is 75% less than it was prior to doing it. And that's switching from a naturally vented furnace to a sealed combustion 94% efficient furnace instead of an 80% efficient furnace. That's actually the roof in Utah going on. So that's the original roof, vent taken off. This will get covered over. I staggered 1 inch foam, 2 inch foam, 1.5 inch foam to end up with 1.5, 2, 3.5, 4. I don't know. I wanted the right thickness for, what's 3 2x4s? 4.5 inches, right? So there's 4.5 inches right out here at the edge of just solid 2x4s. And this is the right amount of foam to get to that. And I staggered them each by 2 inches. So the way we built this is we just cut the bottom pieces so they were staggered, and then you could just keep putting layers up. These are 8-foot 2x4s. So you could get 2 rows of insulation up, get the 2x4s down, put the 8-inch screws in them, put this on, put on a plate to walk on, and just keep moving up the roof. It worked quite nice. You could spray foam on the inside. Currently, all the fire marshals in New England are saying if you're going to do that, you got to cover it with an ignition barrier. So you got to put, there's now a spray ceramic coating you can put over that foam, so it would give you a 30-minute fire rating as opposed to instantly turning into nasty gases. If you're afraid of foam and you want to do an experiment, I have an old steel milk crate that I weld on. I'd always put my favorite test material on the milk crate and then put a blowtorch to it and see what happens. Nothing burns as fast and scary as craft-covered paper on fiberglass insulation, because it's tar-impregnated paper. That's why it says right on it, do not leave exposed to living space. If you hit that with a torch doing soldering on a pipe, your house is gone. It's real scary stuff. I mean, it would be great to sell it in rolls for starting fires in your wood stove, because it's that, I mean, it's like a tender piece of kindling it's like putting a match to a dry cedar shingle that's 30 years old. Pretty amazing. Basements and crawl spaces, fix the site drainage if possible, fix the drainage inside if possible. You'd like to make the basement or crawl space warm and dry. At least you got to keep it dry in winter and summer. So classically, grade around the building is what you do. All the codes say if you got a hill above your building, you need to put a swale between the hill and the building. Without that, you lose. You're basically screwed. Without a swale above your building, you got no chance.
Please explain what a swale means.
Oh, a swale is make sure that there's at least 5 feet going this way before it comes this way so the water can drain away. Okay? And then 5% grade around your building. Do not have water flowing towards your building is what all the codes say. Which is what half the people don't do. So that's where the pond forms beside the house every time it rains. They blamed it on the landscaper. The contractor blamed it on the landscaper. Probably it's the contractor who pitched it the wrong way or didn't backfill it high enough in it. I mean, to backfill it overfill and have an 8-inch reveal between the vinyl siding and the ground, you probably have to fill the dirt right up to the vinyl when you backfill it and then know it's going to settle. Of course, the guy who built my office left an 18-inch reveal because he said, I don't ever want you to have moisture problems. I'd rather have you look at concrete. And my architect said, I won't argue with you. That's the worst thing you can do in this climate. Leave the gutter draining beside your foundation. Let's capture all the water on the roof and dump it beside the footing. Okay? In that particular building, that problem caused a $70,000 mold problem in that basement. The whole basement had to be torn out to get rid of the mold growing in the walls because they had finished basement. If the gutter, you know, looks like that, you need to make it look like that. Having it having it run over with the lawnmower and crunch down doesn't let it do much. You can do surface drainage using a rubber roof membrane to get water to leave beside a building. If you can't get a swale in, at least you'd get in some kind of drainage system. So steps to a basement to make it dry. Don't ever leave wood in contact with concrete, and don't leave cardboard in contact with concrete if you want to keep not having stuff grow. Retrofits for basements include looking at some kind of build out with foam and studs is an easy way to do it, and dry it as needed. Plain old foam will work, and dry it as needed. Squirt foam, which is what you might do in this. There's the squirt foam with a drainage system at the bottom. Lots of contractors now doing this. You basically, can you kill that light for a minute, Wes? I think it'll look a lot clearer, just for briefly, and we'll turn it back on.
That's fine.
That's squirt foam with an ignition coating over it. So you've gone from wet to, and this is actually a parting wall in another apartment, so this is the exterior wall. As long as the drainage outside the building is like this, I have no problems doing this. If the drainage is like that, you probably need to put a drainage mat underneath the foam so all the water that comes through can easily get down to a drain installed at the bottom. And you do need the drain at the bottom. You want to kick that back on? I assume, is that a night light when you, oh, you can shut that off. But I can't have that on and this off, right?
We got 3 options.
Right, but I can't have these off without it. Okay.
No, we can leave it off completely.
No, I don't, when we do the case study, let's leave it off.
Okay.
Well, so there's an example of the same system. I've been in way too many crawl spaces that look like this or worse. Okay. So the real bad news is someone put the insulation on upside down. That was the easy way to do it. It's obviously damp and wet down there. And the bad news is that's where the breathing air for the house is coming from. So whoever's living in this building is breathing a bunch of mold and potentially toxins from the mold that's living in the crawl space.
Again, back up a second, please, just so we're all, please go back. We're up now to the insulation and the crawl space you just had.
Which one?
The insulation in the crawl space, in the ceiling of the crawl space.
Oh, that's
right
great.
There you go. So you said that's in backwards. Does everybody understand why that's backwards?
Well, in theory, that vapor barriers.
I want to see if they pick up on this. Do you understand why that's backwards?
It's the fire retardant. That's the side of the one that burns if you light it on fire, and the way it's supposed to be.
What is the effect? What is the purpose of this?
It's your vapor barrier.
It's your vapor barrier. Where do we want the vapor barrier generally in New England? We want it on the inside, right. I just want to make sure they understand why that was the...
Yeah, but do you want the other side of that argument?
Sure.
What you'd actually prefer to put there is unfaced fiberglass bats, period. And in many installations, what you'd prefer to do is put an inch of rigid foam over that. Because the earth, moisture is always driven from more to less. If the earth is soaked, and that's a crawl space, the more is the earth, not the house.
That was an answer on the midterm, by the way, that a lot of you blew. That one answer.
So,
moisture moves from moist to dry, from more moisture to less moisture.
right. So what I did, the house I live in Maine was built in 1925. I rebuilt in 81. Then I wrote a paper about why it didn't work and rebuilt it again the next year. My first paper was a super insulated retrofit in Maine, Theory and Reality. And I had Gouton Dutt and David Hargy from Princeton come up and help me figure out why the hell I rebuilt the house and it didn't work. because I made it too leaky. The guidance at the time was the house has to breathe, don't make it too tight. So I didn't, and I couldn't heat the thing. You know, on paper, a 50,000 BTU wood stove was supposed to heat the house. I had an oil burner going and a wood stove going, it was still cold. Because I had tongue and groove pine boards in the ceiling. And I didn't have an air barrier above the pine boards. I had that stuff up in the attic. I had 12 inches of fiberglass bats in the attic, which I had a freight train of air coming in everywhere and going out the attic. Stupidity on my point at the time, you know. So what I finally did in my crawl space is I had that. The way I fixed it is I screwed two 3-inch layers of pink foam up on the bottom of that. I put in 3 inches, then I used 9-inch screws to put the second layer on. They sell them for roofing. The house went from something that was so once I fixed the attic I took up all the fiberglass, put down 6 mil poly all over everything, and put the fiberglass back in. Then I blew 2 feet of cellulose over the 12 inches of fiberglass. I heat that building now with a 4-panel solar system and a 30,000 BTU wood stove that gets lit from December through March. And I have a 60,000 BTU propane-fired hydronic system for when no one's home. You know, in general, 50,000 BTUs is heating that 3,000 square foot house, with the exception of when it's 10 below zero, we'll either fire up the other wood stove if it's in an apartment or turn on the hydronics, because it's still not tight enough. When the wind blows, I live 100 feet from the water. I rebuilt the house on the lake in Maine. When the wind blows across that lake and you go to open the back door, there's a freight train of air coming out that back door, because I still can't get the joints I didn't make tight, which is the joint between the floor and the wall and the roof. So.
Well, this leads to an interesting question, which is the law of diminishing returns and where does it stop being worthwhile?
I can tell you what, I don't have the slide. You were asking about insulation? Is that what you...
Insulation, air sealing, the whole kit and caboodle. There's got to be some place where...
Well, air sealing, you should always air seal. Whatever you can afford to air seal, air seal. You'll never waste money doing air sealing. Below a certain level, you have to make sure you got ventilation. This is a workshop we delivered at Public Service New Hampshire the last 2 days. And if you ever get a chance to do it, it's for commercial energy auditors. By all means, think about doing it. Give me one more minute. I got a great slide that'll answer your question, Wes. Now that you will pop the slide. Assuming my computer doesn't blow up with a hernia. This is an internally generated slide by MIAQC. It tries to answer the question, for all these different fuels and systems you could put into a building, and here's the assumptions about the different fuel costs in dollars per therm, when does it make sense to stop insulating? So this is energy loss in dollars per square foot a year. This is essentially different fuel costs. So there's the law of diminishing returns. If you got a real sucky building and you start out with an R5 wall and you're paying $5.25 for fuel, and you say, well, how far should I go? The answer is, what do you want to reduce your fuel bill to? If you'd like to do 5-fold reduction, then you got to go out to R25 or 30 from R5 to get a 5-fold reduction. if you're only paying $3 for fuel and you want to get a 5-fold reduction, what's 3 divided by 5? 0.75 or something? And you want to go out, you got to go, again to R30. So the current guidance for new construction, do you know what the DOE standard for this climate is? I actually don't know, Wes.
For the
Walls and roofs and new homes.
in new homes, R21 in walls, R49 in flat ceilings, R38 in sloped ceilings, but if you have a raised truss, you can get to R30. Oh, no, that would be...
Well, but so here's the simple point. If I build a shell that's easy to insulate, go to whatever you can afford to. If I get an attic and I can blow up 4 feet of cellulose in, so I end up with an R60, the only reason not to do that is cash flow. You know? There's no such thing as I don't get a value from it. There's the law of diminishing returns. Law of diminishing returns is look at the shape of the curve. Once I'm out beyond R30, 35, R40, am I really getting any bang for my buck would be the question. But blowing cellulose in an attic is so cheap. And with another 2 feet, yeah, give me another $600. Now, walls are hard. Walls, I gotta create something I can hang a finish on, I can see out of, and the window well has to look reasonable. And a wall that's much more than a foot thick becomes pretty weird looking wall, and structurally is an interesting challenge. So office is a foot, 2 2x4s, airspace, 2 by 4. Beyond a foot, you know, that's an R35, R40 wall. And it's relatively easy to build. The best bang for your buck, you think which presentation it's in.
I don't mean to draw you off your...
Well, you asked a real great question. I don't know where the slide is, guys. We created a table. The table looks at installed cost for R value. What do you think the cheapest wall to build is for R? Yeah, the highest R value for the least amount of money. Any fiber, whether it's cellulose or blown dense packed glass with 2 inches of foam. Because I got to take care of the stud loss. The dollars per square foot, cellulose is the cheapest living with stud loss. The next beyond that is 5.5 inch blown cellulose dense pack wall with 1 inch of foam on the outside or inside. Bar none is the best wall you could build for the least amount of money.
I've heard people say that the issue with that is that you still get mold growing because the...
Where?
On the inside where the foam meets the fiberglass?
No, not as long as it's an vapor barrier. That's the way my house is built.
Where the vapor barrier is on the inside?
It's a foil covered foam.
Okay, gotcha.
And the foil is facing which way?
In. Yeah. Now, that said, I don't care if you put foil covered foam out as long as it's at least 2 inches. Because the dew point will happen in the foam and no one cares. Foam doesn't grow mold internally. If it happened on the inside of the foam, if you've got a pool, don't put 2 inches of foam on the outside of your building. If you just got a regular building, then 2 inches of rigid foam on the outside, and this climate works fine. Based on, yeah, let's keep going. So, crawl spaces, keep the water out, figure out how to do drainage, use vapor barriers to prevent more water vapor from the soil. In this climate, I always tell people, look, I know you got radon. I know you're going to make the house tighter. Spend the extra money, put the perforated pipe under the poly, put the T on it, stub in for radon before you put the poly down, and test later. If it's high, then figure out how to run a pipe out. Because tearing all the poly back up and then putting a perforated pipe under it is a lot of extra work if you could have done it at the time you put your poly down. It's all relative. The other thing that makes me real nervous is if I put poly down, if I've got water in the soil and I put poly down on my crawl space, what do I know is going to happen under the poly? Condense. It's going to condense. I know when I got liquid water under poly, it's going to, there's some contractors that use black poly, because if you put down clear poly, you see all the shit that's growing under a year later. I know it's going to grow stuff, and I don't want to get a call back from odor. So, you know, plain old poly down on the earth in a sealed crawl space makes me real nervous, because I know you're going to end up with a garden under that poly. This is sealed. That's the whole baggy trick I was talking about earlier, with a sump pump installed so that the water underneath the baggy can go someplace. That's a radon venting system or moisture venting system. You don't have to be a licensed radon contractor to install this for moisture reasons. You only have to do it if you're installing it for radon reasons. Lots of people end up with dehumidifiers in crawl spaces. It's not the solution I'd pick. That's what usually condominium associations pick when they have a moisture problem, because they don't want to spend money to fix it the right way. Then I got a maintenance nightmare. Who's going to keep this thing running? But flood zones today. Anyone ever? No, none of you have been to New Orleans, right? The 9th Ward. That's the way, if you rebuild the house in the 9th Ward where they all flooded and you want flood insurance, that's what they look like.
I don't think you need flood insurance.
You have to build it. And I mean, so you get, what they've done is everyone parks, there's no cross bracing. Everyone parks their car under their house. And there's fire rated sheetrock above the car, so if the car goes up in flames, the house has a chance of surviving. But you drive through the 9th Ward, and all the telephone poles have markers on them where the floodwater line was. And to get flood insurance, you have to build a minimum of 3 feet above that. And most people are building 5 feet above it because it gives you enough room to put your car under the house. So everyone has built-in off-street parking now. And there's stairs going up to the houses. It's sobering, because when you're there, you look out and what you see all around you is what? The dike that broke. What you see, literally the horizon, if you're on the ground looking at all these houses on stilts, your horizon is the dike. And it gives you some idea of when that dike goes, this is a lake. But, you know, interesting dynamics. Summary for moisture. You got to take care of roof water, grading, earth contact, exposed earth. Condensation moisture. Eliminate the moisture source if you can. If you can't, buy a good dehumidifier. What would do this inside a house? And the answer is moisture. That's mold growing all over the door inside the house. Why? Because there's too much moisture. What's the only logical explanation? Because there's too much moisture. Why is there too much moisture? Good question. But the mold grows when there's too much moisture. So you either warm up the wall, which is what blowing in cellulose does, so you don't grow mold behind your couch on the cold wall. And you could do interior, exterior, damp proofing in a basement. Codes tell you to do all that now. One question is, what do you do on the well tank? Any of you live with that? What I got out of workshops is lots of people wrap them with fiberglass and put a trash bag over them. And all that mold growth on your tank's gone. Just like you were wrapping a hot water heater. The trash bag has to go over the insulation because you want the vapor barrier on the warm side, and the tank is what's cold. So drying, you need a real good dehumidifier. The thermistor unit does 100 pints a day. The little thing beside the pot sink does 30 pints a day. The 100 pint a day unit costs you $1,000. The little unit costs you $300. They both use the same amount of electricity. So the big thermistor unit's 3 times as energy efficient as the thing you'd go buy at Walmart. Thermistor.com gets you a $1,000 dehumidifier that works.
That reminds me of a question that I wanted to ask you, which is that I told you we tightened our house up and we're putting in a heat recovery ventilator. My wife is saying, and I've heard this before, oh, we spend all this money to tighten up the house and now we're going to spend money on electricity to
Vent it.
to vent it.
She's right. She's right.
Thanks. That's what I need to hear.
But, well, what else are you going to do?
Well,
Live in a freight train of leaky air? Because
have you seen any numbers on the cost benefit? You know, on that. I mean, it's hard because how do you take into account
cost benefit isn't the analysis. The analysis is controlled ventilation. I got planned controlled ventilation all the time versus I only got enough air when the wind's blowing 30 miles an hour and it's 10 below zero. Other than that, dear, I can open a window. I mean, that's the issue. You could forget all this fan stuff and have instructions carefully placed on the upstairs window and the downstairs window and say, when the wind's not blowing and it's 30 degrees out, open each of these windows 1/8 of an inch. When the wind's blowing 30 miles an hour and it's 10 below zero, close them. When it's 50 degrees out, open each of these windows 2 inches. When it's 60 out, 4 inches. When it's 70 out, open them all the way. When it's 80, close them, turn on the air conditioner. You could do that, but most people wouldn't do that. Finding and fixing water leaks is pretty obvious, usually under tubs. Don't